Welcome. This is a video based upon IPDP AHL TZ1 May June 2022 question paper 1 from question number 11. 1 to 10 has been done in 5 parts. Now this is the 6th part for question number 1. Show that the 3 planes intersect. So for this, what am I going to do? That do not intersect. So I am going to find a normal vector for pi 1 and pi 2. For that, normal vector for pi 1 is 2 minus 1, 2 minus 1 and 1, and another normal vector for pi 2 is 1, negative 2 and 3. I find the cross product. How do I find the cross product? IJK. So let me erase neatly and start writing it out there. IJK, IJK, 2, negative 1, 1, 1, negative 2 and 3. So it becomes I times minus 3 times 2 minus j times 6 minus 1 k times minus 4 plus 1. So it becomes minus I minus 5j minus 3k. So what is the normal vector? Minus 1, minus 5, minus 3. It can also be written as 1, 5, 3. So equation of a line. I am going to find it out, the equation of a line intersecting pi 1 and pi 2. So, or the point line of intersection of pi 1 and pi 2. So we know that from part B, 1 minus 2, 0 is a point. So equation of that line will be 1, negative 2, 0 plus lambda times or plus t times 1, 5, 3. Then I'm going to find it out any point on line L. So it is 1 plus t, comma, minus 2 plus 5t, comma, 3t. Now this should not lie on pi 3. So I'll plug this point on the pi 3. Then they do not intersect. So I am substituting this point in the pi 3 equation. So what does that becomes? I take the pi 3 equation and substitute this one. Let me pull out the pi 3's equation. So it becomes minus 9 times 1 plus t plus 3 times minus 2 plus 5t minus 2 times 3t equals to 32. So we get negative 15 equals to 32, which is a contradiction. So therefore it does not lie. So what is the thing is, planes do not intersect. Planes do not intersect. Verify this point lies in pi 1 and pi 2. So what am I going to do? Plug in this point in pi 1. 2 plus 2 plus 0 equals to 4. Yes. Plug in pi 2. 1 plus 4 plus 0 equals to 5. Yes. Find a vector equation of a line which is perpendicular to L pi 1 and pi 2. So we have already done this one over there. So we can just copy paste over here. So I get the direction first. Once I get the direction, I got the direction there. Then I know it is passing through this point. So therefore, this is the equation of the line L. That is the answer for that part. Now find the vector equation of the line L has been found it out. Now what is being asked? Over here in part D, we missed that part C. Find the distance between the line L and pi 3. We have to find the distance between line L and pi 3. So pi 3 may be like this. Now its normal is this one over here, which is the normal to the plane, which is negative 9, 3 and negative 2. Now L1 is going in this direction, which is not in this one. Now what is this distance? Let this point be A and B. We have to find out the distance between A to B. Let this point is 1, negative 2 and 0. So what am I going to do that? I am going to find the equation of this line. Equation of this line will be 1, negative 2, 0 plus s times minus 9, 3, negative 2. So I'm going to find any point. any point on the line will be 1 minus 9s minus 2 plus 3s negative 2s. It should lie on point B. For which value of s? It should be the point B. So plug in that point in the pi 3. So it becomes negative 9 times 1 minus 9s plus 3 times negative 2 plus 3s, then minus 2 times minus 2s should be equals to 32. So 94s equals to 47. S equals to 47 upon 94, which is equals to 1 upon 2. So the point S will become 1 minus 9 upon 2 minus 2 plus 3 upon 2 minus 2 times 1 upon 2, which is 7 upon 2 minus 1 upon 2 minus 1. Now I want to find the distance between them. So distance is square root of minus 7 upon 2 minus 1 whole square plus minus 1 upon 2 minus minus 2 plus 2 whole square plus minus 1 minus 0 whole square. Simplify that directly. I'm writing that answer 94 upon 4 square root of 94 upon 2. That's going to be the answer. See you in the next video.